Hello everyone. In today's class, we are going to discuss an important set of concepts in Java related to polymorphism and object-oriented programming. So the topics that we are going to cover today are polymorphism, method overloading, using objects as parameters, returning objects, recursion, static members, final variables, and inner classes. So these topics are important not only from the programming point of view, but also from the examination point of view. So while learning these concepts, don't just concentrate on the syntax of the programs, try to understand why we are using each feature and what happens internally when the program executes. So let's start with polymorphism. First of all, what exactly is polymorphism? The word polymorphism comes from two Greek words. Poly means many and morph means forms. So polymorphism literally means many forms. In object-oriented programming, polymorphism means the ability of one entity to take or represent different forms. Let's take a simple real-life example. Suppose you are a student at college, but at home you may be a daughter or a son, and at a workplace you may be an employee. So the person is the same, but the behavior or role changes depending on the situation. Similarly, in Java, a method or object can behave differently depending on the context. So the advantages of using polymorphism are we can reuse the code and it is very flexible and easy to maintain. We can extend and it also supports dynamic binding. Types of polymorphism. In Java, polymorphism can broadly be divided into two types. The first one is compile time polymorphism. It's also called static polymorphism. The second one is runtime polymorphism. It is also called dynamic polymorphism. Compile time polymorphism is achieved through method overloading. That is, the decision is made during compile time. And runtime polymorphism is achieved through method overriding. So the decision is made during execution time or runtime. So in today's class, our main focus is compile time polymorphism and particularly method overloading. Let's now understand method overloading in detail. So method overloading means having more than one method with the same name but different parameter list in the same class. So the compiler determines which method to call based on the arguments passed. So the rules for method overloading are methods can differ by number of parameters or type of parameters and order of parameters, but methods cannot differ only by return type. So let's see an example. So different number of parameters are shown here. So we have a class display and the function is void show. Here no arguments is what we print. Now in the next function, same name is here void show, but we have a parameter here integer a. So here integer, the value of the integer is printing. And now then in the next function we have two parameters integer a and integer b, and we are calculating the sum and printing here. So in the main function, first we are creating an object d, and then when we call d.show, here there is no argument. So the first function will be called and the output will be no arguments. When we call the second function d.show 10, here it checks the argument. So the argument is integer value and only one argument. So the next function, second function is called, and then output will be integer to 10. Then the third function d.show 20, 30. So here we have two parameters. So this function will be called and sum is calculated and displayed as output. So here we have three functions with different parameter list. So this is how method overloading is done with different number of parameters. Let's see another example with different data types. Here again the method name is the same, that is display. But one method accepts an integer and the other accepts as double. So when we write p.display5, the integer version is selected, and when we write call p.display 10.5, the double version is selected, and then the output is displayed. Now let's see another example with different order of parameters. Here we have two functions display. These are also overloaded methods because the order of the parameters is different. In the first function, the first parameter is integer and the second is string. In the second function, first is string value and second is integer value. So when we call t.display 10 Java, the first function will be called, and the second function is t.display programming 20, then the second function is called. Now remember one very important rule. Methods cannot be overloaded only by changing the return type. For example, here we have int add int a int b and double add int a int b. This is not valid method overloading because the parameter list is exactly the same. So the compiler identifies overloaded methods using the method name and parameter list. The return type alone is not sufficient. Until now, we have passed primitive values such as integer, double, and string to methods. But Java also allows us to pass objects as arguments to methods. The call method can access all the members of that object. So this is very useful because we can pass multiple values together and data sharing will be easy, and we can reduce the number of arguments, and it also supports object-oriented programming. Now let's see an example. So we have a student class. It contains two fields, ID and name. So the constructor initializes these values. Student is the constructor. Now look at this method, void display student s. Here we are printing the ID and name. So see the parameter type is student. It is an object. So this means that the method expects a student object as its argument, not a primitive data type. Now we create an object S1, and we are also assigning values as 101 ID and Anu is the name here. Then S1.display S1. So here the object S1 is passed to the method. Here we are not copying the entire object into another object. The reference to the object is passed. So inside the method, S refers to the student object. So both references can refer to the same object. So we use object as parameters when a method needs to work with the data contained in another object, and it is particularly useful when if we want to compare two objects or transferring object information or performing calculations using object data. and for implementing object-oriented algorithms. Returning objects. So Java methods can also return objects. Just like a method can return integer, double, string, it can also return objects like student, employee, or calculator, or any other class type. So these are used in various object-oriented design patterns like factory methods, builder pattern, or method chaining, and to return complex data. So let's see an example. So here we have a class student and it has one field ID, and here we have a constructor student int I. Now we have a function get object. So look at the return type of this method. The return type is student, not void or any primitive data types. Here this is student. Therefore, this method must return a student object or a reference to a student object. Now return this. So here what is this? This represents the current object. So this method returns the current student object. And when we write student S1 is equal to here S1 is created, S1 object is created, and here we have created another object. Student S2 is equal to S1 dot get object. So when we write this, the reference returned by the method is assigned to S2. So both S1 and S2 refer to the same object in this example. So when we display S2, then the output will be 100. That is S1. The next topic is recursion. So this is an important programming concept. So recursion means a method calling itself. So every recursive method must have a condition that stops the recursion. Otherwise, the method will keep calling itself forever. So this is called the base case. So the first is the base case and second is the recursive call. So this is the syntax, basic syntax for recursion. So there will be a condition and then we can use the recursive call. So let's see an example to print numbers. So let's execute this manually. We call print. So here we have print 5. Since 5 is not 0, it prints 5. And then it calls print 4 as here print n1, n minus 1 is here. So it calls print 4. Then it calls print 3, print 2, print 1. And when we reach print 0, then the condition becomes true. If n equal to 0, then return. So the method stops. Now let's take a very important example, factorial. So we know 5 factorial is equal to 5 into 4 into 3 into 2 into 1. That is 120. So here the recursive definition is factorial of n is equal to n into factorial of n minus 1. So this is the base case. Factorial of 1 is equal to 1. So in the program, uh, factorial of 5 is equal to, first it takes 5 into factorial of 4. Then it takes 5 into 4 into factorial of 3. Then it takes 5 into 4 into 3 into factorial of 2. Then it takes 5 into 4 into 3 into 2 into factorial of 1. Then n is equal to 1 and it returns 1. So factorial of 1 is equal to 1. So therefore the answer is 120. Now one common question is what is the difference between recursion and iteration? or are they same? So iteration generally uses loops like for, while, do while. But recursion uses repeated method calls. So recursion can make some problems easier to express, especially problems involving tree traversals, graphs, divide and conquer algorithms, and backtracking. And also recursion consumes stack memory because every method call creates a stack frame. So if recursion does not have a proper base case, it can result in a stack overflow error. So that's the main disadvantage, and it is lower than iteration for simple problems. The advantages are the code is simple and we can use it for it is useful for tree traversal and divide and conquer algorithms, backtracking problems, etc. Now let's discuss static members. So the keyword static is one of the most important keywords in Java. So a static member belongs to the class, not to individual objects, and only one copy exists. So static members include static variables, static methods, and static blocks. Let's see in detail. Now let's discuss static variable. So an instance variable belongs to an object, but a static variable belongs to the class and it can be shared by all objects. So in this program, we have a class student and roll number is the instance variable here and college is the static variable here. So each student has a different roll number, but college is static. That is, the college is common to all students. Therefore, we don't need a separate copy of college for every object. So one static variable is shared among all the objects. Now let's see static method. Static can also be applied to methods and static methods belong to the class and it can be called using class name. So in this program we have a class test and we have a static method called message and here we are printing welcome. So in the main class we are not creating any object. We directly use test.message because the method belongs to the class. No need to create an object. So there are some important rules for using static methods. A static method can directly access static members, but a static method cannot directly access an instance variable. Because an instance variable belongs to an object, a static method can execute without an object. So Java does not know which object is you are referring to. That's the reason. And another important question, can a static method use this? No, because this represents the current object. The static method does not require an object to execute. Therefore, there is no current object associated with the static method. And we can also cannot use super. That is using inheritance. Super is the keyword when we are using inheritance. So super is also not used in static method and it can access non-static members only through objects. Now let's see static block. So Java also supports a static block. A static block is executed when the class is loaded before the main method begins execution. So let's see an example. So here we have a class test and in the static block we are printing static block. Then in the main function we are printing main method. So notice the order. Static block executes first, then main executes. So the advantages of static members are we can save memory, the data can be shared, and utility methods are easy, and access is also faster. Now let's discuss the final keyword. So final Now let's discuss the final keyword. So when we declare a variable as final, its value cannot be changed after it has been assigned. It's like a constant. So example, final int max is equal to 100. Now if we write max is equal to 200, then the compiler will generate an error. So here we are creating an object key, and are when we are printing t.max, we will get 100 as the output, but we cannot change the value. So here we are changing the value as max is equal to 200, then we will get a compilation error as cannot assign a value to final variable max. Now we will see the different types of final variable. The first type is instance final variable. It is just like instance variable, but we are giving final keyword before initializing. So here the value is constant. The next type is static final variable. So very commonly we combine static and final. For example, static final double pi is equal to 3.14159. So why both? Static means one common copy belongs to the class, and final means its value cannot be changed. Therefore, static final variables are commonly used for constants. Now, there is another interesting case called blank final variable. So, this is assigned only once inside the constructor. So, here roll number is declared final, but it is not initialized at the declaration. Instead, it is initialized inside the constructor. So once assigned, it cannot be changed. So blank final variable is initialized inside the constructor. So the advantages are, so mainly we use final. Suppose we have a program where we want to represent maximum number of students as 60. So we don't want some part of our program to accidentally change that value. So we can write final int max is equal to 60. So this makes our intention clear and prevents accidental modification. So the main advantage of using final variable is it prevents modification, accidental modification. And we can also use this for constants, and it improves program safety. Now let's discuss our final topic, inner classes. An inner class is simply a class declared inside another class. So outer one is called the outer class and the inner one is called inner class. So why inner class? Inner classes are useful when a class is closely associated with another class, and it can improve organization and encapsulation. An inner class can also access members of its enclosing class. So there are four commonly discussed types like member inner class, static nested class, local inner class, and anonymous inner class. So the first one is member inner class. Here it is declared inside another class. Let's see an example. So here we have the outer class and the instance variable here is int x is equal to 100, and in the inner class there is a function display and we are printing x. So here inner is a member of out, so it can access the outer class members. So to create its object, outer obj is equal to new outer dot inner in is equal to object dot new inner. So notice this carefully. Because inner is a non-static inner class, we first need an object of outer. So that's why we are writing outer dot inner in is equal to object dot new inner. So we want to create two objects, one for outer class and one for inner. So the output will be 100. Now the next type is static nested class. So this is declared using static keyword. Here we have an example class outer. Then this is the static nested class. Static class inner. Here we have a method display to print static inner. So since inner is static, we don't need an object of outer to create it. So we can simply write outer dot inner obj is equal to new outer dot inner object dot display. Now the next type is local inner class. A local inner class is declared inside a method. So here we have an example class outer. There is a function show. Inside the method, we are creating another inner class. And in that class, we have a function display to print local inner. The inner class is available only within the method where it is declared. So here we are creating an object inner I is equal to new inner inside this one. Okay, and inside this method itself, and then I dot display, because inner class is available only within the method where it is declared. The last type is anonymous inner class. So an anonymous inner class is a class that does not have a name. So here we have an example class animal void sound. So here we create a subclass of animal without explicitly giving the subclass a name. So this is an anonymous inner class, and this is particularly useful when we need a class implementation only once.